If Einstein's theories gave us this incredible map of space-time here in our universe, what happens to space and time well after? You hear it in near-death accounts all the time. Instant travel, a feeling of timelessness. Today, we're diving into a pretty radical idea from a Russian priest, Pavel Florensky. He actually tried to mathematically link our reality with a kind of spiritual imaginary space. Ready? Because we're going to see how quantum gravity, consciousness, maybe even the cosmos itself might connect. It's all here in your deep dive for Le Podcast de Phil.
Okay, let's try and unpack this because it's a big one. We're looking into maybe the ultimate mystery. What are space and time like, if they even exist, beyond our physical life? You sent us, an amazing range of sources. We've got theology, near-death experiences, some really complex 20th century math, and even quantum physics.
Yeah, and what's really striking, I think, is how you see these completely different fields. Religion, philosophy, hard science, kind of circling around a similar idea. That idea being that our everyday experience of time flowing and space separating things, well, it might just be temporary. Or maybe it's specific to how we perceive things right now. So our job today is to sort of weave these threads together for you, from ancient ideas to the very latest theories on the mind, trying to get a handle on what non-temporal existence could actually, feel like or mean.
Right. So where do we start? Maybe with the most direct accounts people give, the experiences and the religious texts, because they almost always talk about time just disappearing or changing completely. Like in near-death experiences, NDEs, people often say whether it felt like seconds or centuries becomes totally meaningless. The whole concept of duration just breaks down.
It really does. And that lines up quite powerfully with a lot of theological thinking, which often frames time as something, well, for us, for humans. Think about the prophet Alma saying, everything is as one day for God, and time is measured only for men. It suggests time isn't some absolute fabric of reality, but maybe more like a measuring tool we need while we're here in this physical state.
Yeah, and Elder Neil A. Maxwell had that great point too. He basically asked, look, if time was our natural home, why are we so obsessed with clocks and watches? Why do we need all these gadgets just to keep track of it? It implies we're not really from time. We belong somewhere else, somewhere timeless, maybe eternity. And our life here is spent dealing with this foreign thing called sequential time.
Dealing with it is a good way to put it. And you see that struggle, or maybe the release from it, in those NDE accounts. Carl Jung, the famous psychoanalyst, had his own NDE, and he described this ecstasy of a timeless state. He said the past, present, and future were just one. Imagine that no sequence, everything just is.
Okay, so if time goes non-linear, what about space? Because that seems to go away too in these accounts. People talk about moving instantly, not flying or traveling, but just thinking of somewhere or someone, and boom, they're there. Like that account of seeing relatives, then thinking of Jesus, and he just appeared instantly. No travel time.
Exactly. Space, or rather distance, seems to lose its power, its limitations. Separation just isn't a factor in the same way. And you even see echoes of this idea in older prophecies. Brigham Young apparently suggested one could visit Jerusalem or China instantly just by wanting to. It suggests that maybe in that state, consciousness itself is location. Your thought is your position. You don't need to move through space anymore.
Okay. Instantaneous, non-sequential. It sounds a bit like chaos, though, doesn't it? If everything happens at once, past, present, future, how does anything make sense? How do you keep track? This feels like where we need some philosophical grounding. Let's bring in Boethius. His definition of eternity from way back in the 6th century is pretty famous, right?
Yeah, it's absolutely foundational for this discussion. He defined eternity as life without limit, possessed completely and all at once. And the key words there are completely and all at once. It's not just time going on forever that's different, that's sempiternity. Think of it like an infinitely long timeline. Eternity, for Boethius, is atemporal. It's outside of time altogether. It's a present moment that contains everything, fixed but infinitely rich, not frozen but complete.
Okay, complete and all at once. But if it's fixed outside our timeline, how does an eternal being interact with us down here in our messy moment-by-moment existence? That sounds like a paradox.
It does, and that's where this concept of simultaneity, ET, comes in. That stands for eternal temporal simultaneity. The idea is that, from our point of view, moving through time, an eternal entity is simultaneously present to every single moment of our timeline. Past, present, future, all at once for them.
Right. So break that down. Let's use the example from the source material about Nixon. How can an eternal being see Nixon resigning in 74, which is past for us, and Nixon dying in 94, which was future then, but is past now? How can they see both as happening now for them?
Okay, think of it like this. Imagine our timeline is a movie reel. We experience it frame by frame, sequentially. An eternal entity isn't watching frame by frame. They see the entire reel laid out at once. They can see the resignation frame and the death frame simultaneously. They know the order, they know one came before the other in the sequence, but their awareness encompasses both points, and indeed all points, within their single, unchanging, eternal present. So the before and after is real for us on the reel, but not for the one viewing the whole reel.
Okay, that makes sense. It's a different mode of perception entirely, which leads us perfectly into this really wild attempt to unify all this using math of Pavel Florensky. So he's a Russian priest, but also a mathematician, early 20th century, and he's trying to bridge the gap between science, particularly Einstein's relativity, and religious or spiritual ideas with math.
Precisely. Florensky wasn't just doing philosophy, he wanted a rigorous mathematical framework. His book, Les Imaginaires on Geometrie, Imaginaries in Geometry, lays it out. He basically proposed that our physical world and the spiritual world are like two sides of one coin, or two faces of a single complex surface, and they're separated by a mathematical boundary.
Okay, wait, a mathematical boundary. What kind of math are we talking about here? You mentioned imaginaries in the title.
Yeah, we're talking complex numbers, those numbers involving I, the square root of -1, which is, a fascinating choice, because in physics, imaginary numbers often pop up when you're dealing with things that aren't directly real in the everyday sense, like rotations, wave functions in quantum mechanics, things that have a magnitude and a phase but aren't just a simple length. Florensky basically said the spiritual realm exists in this imaginary space. It can't be measured with our ordinary real number rulers and clocks.
So if there's a boundary, how do you cross it? This is where Einstein comes in, right? Florensky ties it to the speed of light.
He does. He looked at Einstein's relativity, where the speed of light, c, acts as this ultimate speed limit. Crossing it leads to all sorts of mathematical weirdness, like imaginary mass or time going backward in the equations. Florensky kind of flipped that. He said, yes, c is the boundary, the singularity. But maybe exceeding c isn't impossible. Maybe it's the requirement to transition from our real physical world into that imaginary spiritual world. The mathematical weirdness is the property of the other side.
Wow. Okay. So what does he say happens if something does cross that speed of light boundary?
Well, according to his math, the object or body undergoes this incredible transformation. It effectively loses its extent, meaning its physical size collapses. It passes into infinity and gains absolute stability.
Right.
It essentially becomes like a Platonic idea, pure form, eternal essence, no physical shape, unchanging. And crucially, once you're in that imaginary space, concepts like cause and effect, which depend on time, become irrelevant because that realm exists outside our kind of time. It's his mathematical way of explaining timelessness and spacelessness.
That is a serious leap. Connecting relativity, imaginary numbers, and Platonic forms. It's mind-bending. But if Florensky put the boundary out there at the speed of light, maybe modern physics suggests the boundary could be much closer, maybe even inside our own consciousness. Let's talk about the Penrose-Hameroff model, ORC or R.
Right, orchestrated objective reduction. This is a very different approach, coming straight from physics and neuroscience, but it resonates in interesting ways. Penrose and Hameroff argue that consciousness isn't just brain cells firing in complex patterns, like a biological computer. They think it's connected to something deeper, to the fundamental physics of space-time itself, happening at the quantum level, specifically inside tiny structures within our neurons called microtubules.
Microtubules. Okay, so what's the proposed mechanism? How do these tiny structures supposedly link to quantum gravity and create consciousness? This sounds pretty complex.
It is complex, but the core idea involves quantum superposition. Think Schrödinger's cat, but with proteins inside these microtubules. These proteins, called tubulins, can supposedly exist in multiple states simultaneously, a quantum superposition. ORCH-OR proposes that these superpositions build up until they reach a certain threshold, a threshold defined by quantum gravity, basically by the structure of space-time geometry itself.
Okay, so they're in multiple states, they reach a limit. Then what?
Then they collapse. Spontaneously. This isn't like someone measuring them. The system collapses on its own due to this quantum gravity threshold. That's the objective reduction, or part. It's a real physical event, a self-collapse. And crucially, it's instantaneous and non-computable, meaning it's not something a classical computer could predict or simulate.
So wait, each one of these instantaneous collapses, that's a moment of conscious experience.
That's the proposal, exactly. Penrose calls each collapse a selection of space-time geometry. Think of it like reality, choosing one configuration out of many possibilities that instant. Whitehead called similar ideas occasions of experience. And our feeling of a smooth stream of consciousness, our subjective experience of time flowing, that's supposed to be generated by a rapid sequence of these discrete aurora events, these individual conscious moments happening one after another very, very quickly.
Whoa, okay. So if our subjective feeling of time passing is actually built from these tiny, discrete, quantum gravity-based collapses inside our brain, it means our experience of time isn't just us observing an external clock. Time for us is somehow being generated by these conscious moments.
That's the radical implication,
Yeah.
yeah. It flips the whole thing. Instead of consciousness existing within time, maybe subjective time emerges from the process of consciousness itself, moment by moment. And you can see how this might connect back, conceptually at least, to those NDEs. If the mechanism generating the sequence of conscious moments, the or-char process, were to stop or change fundamentally, perhaps the experience of sequential time itself would dissolve, leading to that feeling of timelessness.
So wrapping this all up, where does this leave us? We've looked at these really different perspectives. On one hand, the spiritual and experiential accounts pointing to this timeless, spaceless existence. And on the other, these complex mathematical and physical theories, Florensky using imaginary numbers and the speed of light as a boundary, Penrose and Hameroff linking consciousness to discrete quantum collapses in space-time geometry.
Yeah, and despite the vastly different starting points, there's this fascinating convergence on the idea that our normal everyday perception of time ticking by and space stretching out, well, it might not be the fundamental reality. It seems to be tied to our current physical state, or maybe to the boundaries defined by things like the speed of light, or perhaps even the quantum processes generating consciousness itself. If you cross those boundaries, the nature of time and space seems to fundamentally shift, or even dissolve.
This deep dive really has bridged some unexpected territory from, ancient philosophy to the edge of quantum physics. And it leaves you with a pretty provocative thought, doesn't it? If our own subjective time is just this stream of incredibly fast, discrete, instantaneous selections of reality, these quantum collapses, how different really is that process from the idea of an eternal being perceiving all moments all at once? Maybe the difference isn't in the what, but the how fast or how completely those moments are perceived or selected. It really makes you wonder about the underlying structure of it all. You've been listening to this deep dive on Le Podcast de Philippe. If you enjoyed this journey through space-time, consciousness, and everything in between, please do help us reach our goal of 1,000 subscribers. We're really close. Your support makes these dives possible. Thank you again for sharing these incredible sources with us. Until the next deep dive, keep questioning.